A student investigates the reaction of large pieces of calcium carbonate with dilute hydrochloric acid at 20 degrees centigrade. The hydrochloric acid is in excess, so hydrochloric acid is excess. Now complete the equation for the reaction by adding state symbols. Calcium carbonate is a solid, hydrochloric acid aqueous, calcium chloride given aqueous, water liquid, carbon dioxide gas. Now this deduce the volume of carbon dioxide gas released after 40 seconds. You will get answer from graph 34. How you get after 40 seconds? You count it. So 40 seconds is this. You will this point. So 34 value is given from here. Volume of carbon dioxide is 34. Next, the student repeat the experiment using the smaller pieces of calcium carbonate, small particles. So all other conditions stay same. Draw a line on the grid to show how the volume of carbon dioxide changes when smaller pieces of calcium carbonate are used. And a smaller particle or smaller pieces have greater surface area, so rate of reaction will be faster and graph will be more steeper compared to the others. So this is the when this line will be more steeper when small pieces of particles is used, but total volume of carbon dioxide will be same. Graph will be more steeper, but total volume will be same, because rate of reaction is high when small particles surface area greater, so rate of reaction is high and graph is steeper. See, the student repeat the experiment at 20 degrees centigrade. All other conditions same. Describe and explain using the collision theory how the rate of reaction differs when the temperature of 20 degree is used. And you see, previous temperature was 25 degrees centigrade. You see here, previous temperature was 20 degrees centigrade, now 20, decreasing temperature. And decreasing temperature, rate of reaction will be decreases. So your answer will be rate of reaction decreases as 20 degree centigrade temperature is less than 25 degree centigrade. So rate of reaction decreases. Why? Particles have less kinetic energy. Particle has less kinetic energy, so fewer successful collisions occur per unit time. I mean, rate of reaction decreases because temperature is less, so particles have less kinetic energy, so less successful collisions occur per unit time. That's why rate of reaction decreases. And D, a sample of carbon dioxide is put into a gas syringe. The end of the gas syringe is then blocked so that no gas can escape. Now explain using kinetic particle theory why increasing the pressure in the gas syringe decreases the volume of gas when the temperature stays same. If you increasing the pressure, volume decreases because particles become closer. The particles are closer together, that's why volume decreases. Now number 4, concentrated aqueous magnesium iodide is electrolyzed using graphite electrodes. Predict the product as at each electrode. So anode, you know, iodide ion oxidized to produce iodine, and at the cathode, at this is aqueous. So when it will be aqueous, at that time at the cathode, hydrogen ion gains electron to produce hydrogen. At the cathode, product will be hydrogen. At the anode, product will be iodine. Now molten magnesium iodide is electrolyzed using graphite electrodes. Construct the ionic half equation for the reaction at the cathode, at each electrode, I mean at the cathode and at the anode, when molten magnesium iodide is electrolyzed. And you know, at the anode, iodide ion lose electron, minus means loss electron, to form iodine. Or you can write left side minus electron means right side you can plus, same thing. And at the cathode, as molten, so as molten, if molten magnesium iodide, if molten metal ionic compound, at the cathode metal will be produced. So at the cathode, magnesium ions gains 2 electron to produce magnesium. Magnesium ion gains 2 electron to produce magnesium. But when aqueous, then hydrogen will be product at the cathode. When molten, metal will be, I mean magnesium will be product. Now describe a test for aqueous iodide ion. Include the observation for the positive test. And you know, iodide ion test, I mean halide ion test, reagent nitric acid and silver nitrate solutions are added, yellow precipitate is formed. So you confirm that this is the test for iodide ion. Reagent nitric acid and silver nitrates are added, yellow precipitate is formed. Next, iodide ion reduce manganese 4 oxide to manganese 2 ions. Iodide ion, manganese 4 oxide reduced to manganese 2 ions. This is the manganese 2 ions. This is the manganese 4 oxide. Here manganese oxidation number 4 plus 4, here plus 2. Now you are asking, explain in terms of movement of electrons how iodide ions act as a reducing agent in this reaction. Reducing agent means reduces another substance but itself oxidizes, means it reducing agent lose electron. So iodide ion gives electron to the manganese in magnesium 4 oxide. So iodide ion lose electron, iodide ion gives electron, lose electron, that's why it works as a reducing agent. To state the name of type of reaction that involves simultaneous oxidation and reduction, this is known as redox. Simultaneous oxidation reduction means one electron is oxidized and other element is reduced. That reaction is known as redox reaction. Simultaneous oxidation and reduction reaction is known as redox reaction. Now phosphorus triiodide Pi3 is produced when phosphorus reacts with iodine. To show the dot and cross diagram for a molecule of phosphorus triiodide, phosphorus 3 iodine. Now phosphorus is a group 5 element, so it has 5 electrons in its outer shell. So it gives here 1, 2, 3. So remaining 2 non-bonding electron or lone pair electron. Now iodine is a group 7, so it has 7 electrons in its outer shell. If it give 1 electron here, 2, 4, 6 remaining non-bonding electron, lone pair. Every iodine 2, 4, 6, 2, 4, 6. Next,